Subscribe to our YouTube channel and press the bell icon to get latest notifications.
Assalamu alaikum students. In the previous lecture we discussed the laws of refraction of light, and in the laws of refraction of light we came across a topic called refractive index. Today we will discuss what's the concept of refractive index, what does its numerical value signify. Now, refractive index, it is one of the ratio, it's a numerical value. But from concept point of view, what refractive index is, we know the speed of light in different media. The speed of light in different media is different. The medium is actually responsible for determining the speed of light. For example, in air, the speed of light is, in air or vacuum, the speed of light is 3 into 10 raised power 8 meter per second. But in glass, the speed of light is 2 into 10 raised power 8 meter per second. The light is same. Once the light travels from air to glass, it slows down. The speed of light slows down. That is, something is responsible for change in the speed of light, and that change occurs due to change in medium. That change in speed of light occurs due to change in medium. Now, this medium is actually responsible. This medium is actually responsible for changing the speed of light. Light in air is traveling faster, but the same light is traveling in glass or water. It's traveling at a slower speed. What is the reason? The concept behind this is, it's actually the medium. It's actually the medium that is responsible for changing the speed of light. Now, the medium has different characteristic properties. One of the properties of medium is whether it's transparent, whether it would allow the light to pass through it or not. Fine, it's one of the property of medium. But the other property, one of the property of medium that actually governs the speed of light, one of the property of medium that actually governs the speed of light through it, like air. Air allows the light to travel at a speed of 3 into 10 raised power 8 meter per second. But the glass, it has such a property for the propagation of light that it does not allow light to travel faster through it. It allows light to travel at a speed of 2 into 10 raised power 8 meter per second. Fine. So it is actually the property of the glass. It is one of the property. Glass has many properties. This medium air has many properties. But we are only concerned with that property of glass, that property of air, that property of water, that property of medium, which is actually governing the speed of light through it. That property, that is actually responsible for the speed of light in that very medium. That particular property is known as refractive index. So refractive index is actually one of the properties of medium. It is the property of medium. Which property? Which property? This medium has many properties, but we are concerned with only one property, and that property which would determine the speed of light through it. The property of the medium that would govern the speed of light. Now we have to measure, we have to give the measure of that property somehow. The measure of that property is given in terms of a numerical value. If this very particular property of medium, the property that is responsible for the speed of light, that is responsible for whether it would allow the light to pass to travel faster through it or not, that very property is measured in terms of a numerical value. If the numerical value of that property is large, or simply more the value of that very property, that is refractive index, it means it is more the denser the medium is. the property that is responsible for determining the speed of light. If that property has a large value, larger the value of the property, more the value of this property, refractive index, more the value of this property, it means this medium would not allow to travel light faster through it. The speed of light through this medium would be less. Similarly, lesser the value of this property, that means if the numerical value of this property is less, it suggests that the medium is rarer, medium is getting rarer. If the value of this property is 3, for other it is 2, for other it is 1, it means the value of property of 3, the medium which is having the value of 3 for this very particular property, it means that the speed of light in this medium would be the slowest. Similarly, it would be slightly faster than this, and it would be fastest in this medium. So, lesser the value of this property, more will be the speed of light in that medium. More the value of this property, less will be the speed of light in that very medium. So, refractive index is one of the properties of medium that would determine whether the light would travel faster through it or slower. Or in other terms, we can connect it directly with the refraction. The more the value of refractive index, or the refractive index is such a property which would determine how much light would bend. How much light would bend when it travels from one medium to another. So, greater the difference of the refractive indices between the two media, the more change in the speed of light, the more bending. So, this property of the medium that would actually determine the speed of light through it. If this very particular property of the medium has more value, it means the speed of light would be less. If the value of this property is less, it means the speed of light would be more in this medium. So, it is that property that would determine the speed of light. It is that property that would determine the speed of light, or the change in speed of light from one medium to the another medium. That property that would actually determine the refraction, how much refraction would take place. That property that would actually determine the extent of refraction of light. So this very particular property would determine the speed of light through a particular medium. So if the value of this property is more, it means the speed of light through this medium is less. If the value of this property is less, it means the speed of light would be more. So this property would determine the extent of refraction of light. So refractive index, from concept point of view, it is that property of medium which would determine the speed of light through it. So we get a numerical value for this property. Now the question is, how do we get the numerical value of this property? We get the numerical value of this property by a simple ratio, and that very ratio would actually give the definition of this refractive index. So refractive index, it is the ratio of speed of light in vacuum or air to the speed of light in a particular medium. It is the ratio of speed of light in vacuum or air, which is approximately same, to this speed of light in medium, the medium which you are talking about, whether it's glass, air, water, diamond, whatever. This ratio is called as refractive index. So refractive index is simply speed of light in vacuum denoted by c. C denotes the speed of light in vacuum or air, divided by speed of light in medium, V, speed of light. This C is also speed of light, this is also speed of light. C denotes the speed of light in vacuum or air, V represents the speed of light in media. Refractive index, as we know, it is denoted by mu. Mu is equal to C by V. Mu is equal to C by V. Mu means refractive index, C means speed of light in vacuum in air, or speed of light in vacuum or air, and V represent speed of light in medium, where C is always known. C is the speed of light in vacuum or air, which is equal to 3 into 10 raised power 8 meter per second. Fine. So the C is always known, C is constant, the speed of light in vacuum, which is 3 into 10 raised power 8 meter per second. So with the help of this formula, we can actually calculate the refractive index of a particular medium. Once we know the refractive index of a particular medium, for example, we got to know that the refractive index of this medium is 2.2 and the refractive index of other medium is 2. So we get to know that it is optically denser medium, and it is optically rarer in comparison to this. That is, the speed of light in this medium would be, this is having more refractive index, so the speed of light would be less. This is having less refractive index, so the speed of light would be more. So this medium would be optically denser in comparison to this, so this would be rarer. Okay, so the refractive index would give us the extent of refraction of light. The refractive index would give us the measure of a property of a medium that would determine the speed of light through it, and the refractive index is simply defined as the ratio of speed of light in vacuum to the speed of light in medium. When we use this formula, it is known as absolute refractive index. Speed of light in vacuum to the medium is known as absolute refractive index. When we compare the two media, refractive indices, indices is plural of index, When we compare the refractive indices of two media, that is known as relative refractive index. Here it's known as absolute refractive index. Okay, so refractive index is simply nu is equal to speed of light in vacuum to the speed of light in medium. For example, the statement, there is a question, the refractive index of diamond is 2.25. What does this mean? What does this statement mean? The refractive index of diamond is 2.25, for example. What does this statement mean? What does this statement mean? This statement means we are given that refractive index is 2.25. We know the refractive index, when we calculate this refractive index, it is always calculated in comparison to the speed of light in air. So it means the refractive index of diamond is 2.25. It suggests that the speed of light in diamond is slower. Speed of light in diamond is slower. How many times? 2.25 times. Speed of light in diamond is slower. How many times? 2.25 times than in vacuum or air. Now you can clearly see what exactly refractive index is used for, or what's the concept behind refractive index. We are simply given with this statement that mu for diamond is 2.25. What does this statement mean? So this statement means that the speed of light is slower in diamond 2.25 times than in air or vacuum. Clear? Okay. So refractive index simply gives is the property. It is the property of the medium, and that property of the medium which would determine the speed of light through it. Like there's another question. Light travels from air to glass. Light travels from air to glass having refractive index 1.5. Light travels from air to glass having a refractive index 1.5. What is the speed of light in glass? What is the speed of light in glass? Light travels from air to glass having refractive index 1.5. So we are given with the value of refractive index, which is 1.5. The other thing we have to calculate, that is speed of light in glass. So we have to calculate the speed of light in a particular medium. Let's write the formula. Mu is equal to C by V. Mu is given 1.5 is equal to C, we know, 3 into 10 raised power 8 meter per second, divided by V, speed of light in medium. Here at this time the medium is glass, so we have to calculate this speed. So V will be equal to, we will transpose it, 3 into 10 raised power 8 meter per second. This 1.5 would come in the denominator of 3. So V is equal to 3 into 10 raised power 8 meter per second divided by 1.5. V is equal to 3 divided by 1.5, which is equal to 2. 2 into 10 raised power 8 meter per second is the answer. So the speed of light in glass is equal to 2 into 10 raised power 8 meter per second. So we can calculate the speed of light in any media with the help of refractive index. Once we know the value of refractive index of a particular medium, we can calculate the speed of light in that very medium. So refractive index deals with the speed of light. Though it is the property of medium, but it is related to the speed of light. It is the property of medium that would actually determine the speed of light through it. And with the help of this formula, we can know what is the speed of light in different media, or we can calculate the speed of light in a particular medium. Inshallah, we will discuss the next topic in our next lecture. Thank you.